Welcome to The Metabolic Link, a podcast that explores the common thread of metabolism in health and disease. This is where science meets society. Welcome back to another episode of The Metabolic Link. Today, we're sitting down with Dr. Sachin Panda. And Dr. Panda is a professor and a research scientist at the Salk Institute. His research focuses on circadian biology, on behavior, and really on the science and the application of time-restricted feeding. Much of what I've learned on time-restricted feeding has come from him. He's done the seminal work on this topic. In this chat, we cover the importance of circadian rhythm, lifestyle choices that impact them, and how circadian biology changes our metabolic health. And most important, how we can implement time-restricted feeding and how it can be integrated into our lives. We cover a lot of ground on this episode, and we also cover a lot of questions that I get asked repeatedly. So I think you'll enjoy this podcast, and I think you'll find it interesting and informative. And I look forward to sharing this content with you, and I hope that you share it with others too. Thank you. Dr. Panda, thank you for being here. Can you briefly explain circadian influence on metabolic control and also glycemic regulation?
Yeah, so we humans have been living on this planet for 200,000 years, and one constant over the last 200,000 years is we are programmed to eat mostly during the day and go through overnight fasting and sleep at night. So that's why our physiology, metabolism, even hunger, satiety, all these signals have been optimized to eat within certain number of hours when our digestive system is optimum to digest and use nutrition, and then fast for the remaining hours. So that means every organ has a peak time when we can digest food. Also have a downtime when food can be detrimental. So that's the 30,000 feet view of physiology, metabolism, and circadian rhythm. But when we drill down and look at every digestive juice, hormones that regulate metabolism, hunger, satiety, and enzymes that utilize nutrient, then what we find is almost at every level of this regulation of metabolism, there is circadian rhythm. So that means our stomach is optimized to digest food at certain time, our liver is optimized to use carbohydrate or burn fat or use amino acid at specific time of the day or night. And similarly, our hunger and satiety is also programmed so that if we respect our circadian rhythm, we also have low hunger at bedtime. So we can go through that long overnight fast and use fat during the fasting time. So that's what we are learning from molecules to behavior and even evolutionary trend, how circadian rhythm optimizes glycemic control.
Intuitively, I kind of thought this was important, before I even knew anything about circadian disruption and circadian patterns growing up. But we know that there's big effects on circadian rhythm influencing metabolic control, digestive hormones, and even sort of neuropharmacology probably associated with eating. Nutrition researchers may be less familiar with time-restricted feeding, may contend that the metabolic effects in regards to weight loss management, body composition alterations of time-restricted feeding or eating are linked exclusively to the effect on caloric restriction. So eating within a compressed time window will inadvertently likely produce some degree of calorie restriction. Would you agree with that? And would you also, because it's quite a big debate, I teach at the medical college, and the medical students reviewed a bunch of time-restricted feeding and intermittent fasting, and the general consensus of the group was that time-restricted eating, the benefits are exclusively linked to the caloric restriction effect associated with that.
Can you define what are the benefits other than weight loss?
define the benefits other than weight
Yeah,
loss.
because
Yeah.
you said that
Yeah.
exclusively linked to time restricted eating. And my question is, have you read our basic biology mouse papers where calorie by calorie we control everything?
Yeah. So this is where I think it becomes very interesting because most of the people contending this are really not familiar with the time restricted eating literature, your literature. But we had kind of a debate, and I was on the side that, kind of justifying time restricted, citing your papers and a couple other. But when it comes to like human data on weight loss and weight maintenance, I don't know if
Yeah,
you're
so weight
aware of
loss is a
any.
very different issue because time restricted eating has numerous benefit, and people just get latched onto weight loss.
Yeah.
But we and others have shown that the benefits are disproportionately bigger than the weight loss, and that's actually published. And also Courtney Peterson, when she controlled calorie by calorie, of course there is no weight loss. You won't expect weight loss within few days, but the benefits on insulin sensitivity and blood pressure, those are completely independent of weight loss. I guess people get latched onto this idea that improving health means you got to lose weight. And in that way, people miss out that there are many healthy overweight and obese people, and also 1/3 of adults are actually not overweight or obese, but they still suffer from many chronic disease. And what will be nutritionist advice for the 1/3 of people who are actually normal weight? There is nothing there except you change nutrition quality, which is very difficult to do. So the time restricted eating, of course, this is a very new field. Caloric restriction has a history of almost 100 years. So anything imaginable has already been done in caloric restriction. But I also argue that caloric restriction does not explain most of the benefits that are seen in caloric restriction, because people assume that caloric restriction actually leads to most of the benefits. But if you do a careful analysis, even in calorie trial, only 40% of weight loss was explained by caloric restriction. And we know that in many caloric restriction studies in humans or mice, people also inadvertently adopt time restriction. So I would also argue that many benefits of CR may be actually TR. So I guess this is I think in the coming days, we'll just see more and more molecular results linking both ways. What are the benefits of CR that may be mediated through TR? And what are the benefits of TR that may be mediated through CR? And we also have to keep in mind that time restricted eating improves sleep quality, which is a huge impact on quality of life. Caloric restriction actually deteriorates, in some cases, sleep because of extreme hunger at bedtime. So I guess we have to keep in mind the whole physiology, metabolism, and behavior in the context of health, and just not get tied to weight loss.
Yeah.
I agree.
Yeah,
Weight loss, for big weight loss, you need to reduce calorie. There is no doubt about it.
Yeah.
But it's premature to say that the effect of time restricted eating is exclusively mediated through CR. That's wrong.
Yeah. So I totally agree. And and shift workers too have a whole panacea of problems, including metabolic health problems. So it's likely that a certain percentage, it's hard to link it because it's probably going to be individualized, of the benefits are due in some part to calorie restriction. But I mean, it's very clear, it's a very nascent field as far as the research that you're advancing on this topic. But I think as science emerges, we're going to have a better understanding of that.
I think even for translation, for example, among all the people who are listening or watching this video, I bet most of them cannot figure out how many calories they have consumed since morning until they watch the video. But almost all of them can tell at what time in the morning they had their first calorie. So if counting time is so much easier, And if counting time can inadvertently improve nutrition quality and reduce some calorie, then what's wrong with it? I mean, this is easily
Yeah.
translatable. Nobody has to go and count calories and read every single nutrition label and do the mental math throughout the day to figure out how much calories and what proportion of calories they got from measure macronutrients.
Hmm. Yeah, and I think you really do get a twofold effect in that, you're eating to optimize your circadian biology and metabolism. And for people who do need to lose weight, it's a very effective form of caloric restriction in doing that, because it probably corrects your feeding hormones, ghrelin, leptin, insulin signaling, and glycemic control, which then in turn corrects your eating behavior. I mean, maybe one could argue about that. I mean, in the beginning, when you do it, it might be a little challenging, but the more you do time restricted eating, the easier it gets, and probably the more benefits you derive from it over time. So one of the benefits that I wanted to ask you about was the microbiome. And I don't know if the literature's in humans is clear on this yet, but we all have different microbiomes. Are there any consistent observations that you see in people implementing time restricted eating on their microbiome in regards to diversity or shifts in the microbiome?
There is not much study in human. And another
Yeah.
thing is, yes, in humans, people always look at the fecal microbiome because that's easier to
Yeah.
collect and analyze. But we miss out on most of the microbiome that's involved in digestion and absorption of food. So we haven't done much in human, but in mouse, we know that it actually increases the cyclicity of some microbiome, and it changes the microbiome diversity in a way that the mice can actually excrete some of the sugar and fat in the fecal matter, than instead of absorbing, they actually secrete it. So we don't know whether that translates to human. So it's yet to be seen how that translates to human.
Okay. One question I had, and a couple of people have asked about the potential for gallstones or gallbladder, I think gallstones, as a potential consequence for more extended, time restricted eating, or maybe that was with
There is absolutely no
no.
study
Okay.
done in this century that connects.
Okay.
This is
Oh,
some myth from 1970s or 80s when people are already eating very little. And yeah, absolutely, this is just myth that spread.
okay.
No single manuscript, whether in mouse or human, in this century that links gallbladder or anything with these two. So let's move
That's
on.
that's good. That's good to know. Maybe that's why the person didn't follow up and send me a paper.
Yeah,
I said
yeah.
I'd like to see a paper. So melatonin. So you're very familiar with melatonin. It's a sleep aid that I've been using for over 2 decades, 2.5 decades now. I'm also in touch with people using mega doses, 2,000 to 3,000 milligrams per day for alternative medicine approaches to cancer management. So melatonin has, I did research a couple decades ago on the hippocampal brain slice preparation, where I gave melatonin at different doses in hippocampal slice preparations that were maintained under 20, 40, 60, and 95% oxygen. And I observed that mitochondrial function, superoxide anion, we measured that with dihydroethidium, and a bunch of other things improved pretty remarkably. So I've always, ever since then, back in the 90s, I was, taking melatonin as a supplement. So I take it mostly as a neuroprotective compound, because it is, in our studies, work funded by the military, pretty effective. But they did not want to use it because it could make you sleepy. So the people that I talk to taking very large doses don't seem to be sleepy. And I imagine that they just habituate to that. So I wondered, that why there's widespread use of melatonin as an over-the-counter sleep aid, probably better than things like diphenhydramine and other things on the market. What are your thoughts on the widespread use of melatonin, and you think there's any potential implications for using 5-10 milligrams per day?
Well, there are a few things. One is when it's over the counter, we also don't know about the purity and what else is mixed with this. So it's hard to comment. And melatonin is one hormone where you can, uh, I won't say there is no LD50 for mouse, but you can actually dump a lot of melatonin in mouse or human, and there is no lethal dose of melatonin. And why is that? Because vast majority of melatonin is actually metabolized very quickly, degraded in the liver and kidneys. So even if people may be dumping a lot of melatonin, um, a good portion of it, more than 90% of it, is metabolized right away. And going back to some in vitro study, I also question whether the in vitro studies will translate to in vivo, because when melatonin is degraded so quickly, our organs and cells are actually exposed to relatively less amount of melatonin than what we use in physiological experiment.
Mm-hmm.
And in terms of melatonin, it's also interesting to see, like over the last 20 or 30 years, if you look at the dose of melatonin that's marketed, 2 decades ago, you could easily find 1 milligram melatonin pill. Not anymore. It's really hard to even find 3 mg melatonin.
Yeah.
Mostly it's 5 mg or more. So I guess this is, if people are benefiting from it, that's okay. But I must put two caveats that we don't know the purity of many of these melatonin pills, and second is, since melatonin is rapidly degraded, and this degradation can vary from person to person, everybody should try to dose their melatonin themselves. So some people are very sensitive to melatonin; even 1 mg can knock them down. Whereas others are very resistant, they may need 3 to 5 mg. And people should try, particularly try them when they're not traveling.
Yeah, I measure melatonin too in the blood with different kits. And I do notice that even 3 milligrams at 9 p.m., if I take my blood at 8 a.m., it's way high. It's extremely high. So this was kind of alarming to me, but being in touch with people taking 2,000, 3,000 milligrams, saying it keeps them calm and makes them, I think they're going into uncharted territories, but it's they seem to be sleeping well. And
I think it'll be good to see some really clinical trial where people are measuring their blood plasma level and also doing EEG and other stuff to see how they're sleeping, looking at the physiology and glucose regulation as well, because melatonin does make your pancreas to sleep. So that's a new study, new knowledge in human biology, that melatonin can reduce glucose-induced insulin secretion. So that can have implication for people who are at risk for diabetes.
Yeah. I want to have some questions about circadian disruptors and mitigation strategies or countermeasures that we can do for mitigating the negative effects. My parents were visiting last week. They had a 6 a.m. flight, had to wake up at 3 a.m., which is 4 hours earlier than I normally do. And I did see it. I wear a continuous glucose monitor, a Dexcom. And I did notice this, I was about 10 to 20% higher throughout the morning. I felt very wired. I think my sympathetic nervous system and cortisol were probably high, although I didn't measure it. So I know, circadian disruptors are inevitable in modern society. And I wonder, and I know that, what are 3 things that people can do to optimize their circadian biology? And also I'd like to hear more about, and I was at the website yesterday, mycircadianclock.org, and what you're doing with that app and how it's really advancing the science into human application and collecting data through that app. It's very interesting.
Yeah, so as you said, almost all of us experience some kind of circadian disruption. That means sleeping or eating at random time at least 1 or 2 days in a week. So if you stay awake for 2 hours between 10 p.m. and 5 a.m. for at least 1 or 2 days in a week, then you're actually living the life of a shift worker. And almost all of us are living the life of a shift worker. So a few things that disrupt circadian rhythms are exposure to light, particularly late night, evening, bright light. Second is eating randomly or eating late into the night, And then third one is sleep disruption, because when we sleep less, then it has a cascading effect. So then three things that people can do is to try to go to bed consistently around the same time and be in bed for 8 hours in a cool, dark room, so that you can get at least 7 hours of restorative sleep. After waking up, avoid food for 1 or 2 hours, because that's when your nightly hormones are going down, day hormones are coming up, and your body is not prepared to digest food properly. And then after you eat your breakfast consistently around the same time and eat all your calories within 8, 9, 10, or maximum 12 hours, not longer than that. The last calorie should be 2 to 3 hours before bedtime, and avoid food and avoid bright light 2 to 3 hours before bedtime. So it's sleep for 8 hours, eat for 8 to 10 hours, and then avoid food and bright light 2 to 3 hours before bedtime. Those three should be something that most people can follow. And then for
Very
the
good advice.
yeah, and for the My Circadian Clock app, we developed the app a few years ago because nutritionists seriously questioned whether humans actually eat like mice, and many contested that people eat 3 square meals a day within less than 12 hours. We had no good paper showing that was true. So that's why we started the app. It's a completely academic app. So that means we don't share data with any commercial entities. What we found is in the US, average humans who are not doing shift work, they're likely to eat over a period of 14 hours, 45 minutes. So 50% of adults eat over a period of 14 hours, 45 minutes. And less than 10% adults actually habitually eat in less than 12 hours. So that was an eye opener. And since then, we have been using this app to collect data and also to guide people on how to eat and sleep properly. And this app is being used in 12 ongoing clinical trials on the impact of circadian optimization on obesity, diabetes, cardiovascular disease, even cancer, and recovery from cancer. So I published quite a few papers, but in future we'll see more. So the biggest thing is when people log or track their own lifestyle. There are many commercial apps, but by using this My Circadian Clock app, they're actually doing something like a citizen science project where they're sharing their data, and at the same time we can figure out what are the barriers to living a healthy lifestyle and how people accommodate their existing lifestyle to optimize circadian rhythm. And this is helping us to do better and better studies.
So that is fantastic. Is the app being used in IRB approved clinical research? Is that right? So the data is from the backside or the dashboard, it's de-identified?
It's all de-identified, and the data is also encrypted in transit, and people have to agree to a consent when they download the app to share their data.
Okay. Yeah, I'm part of a low carb ketogenic diet study where we're promoting, and most people prefer to do time restricted eating because that's when we actually get the results that we want.
Also get better compliance.
Yes, that's right. Yeah, better compliance. So yeah, I would definitely, I'm going to maybe have some follow-up questions for you offline about incorporating that into some clinical trials that we have ongoing. So, well, I know we're kind of coming up on time, and Dr. Panda, I really thank you for being very generous with your time. We really appreciate your insights and the actionable information that you're putting out there, especially in your book. I would really advise people to check out the Circadian Diabetes Code, which is really the essence of optimizing your circadian rhythm for metabolic control. So. And are there anything else that I missed that I can sort of direct people and help people find out more about what you do?
I think you covered most of the stuff, and I must say that many effect of time restriction may actually go through ketogenesis. So there is some synergy. At least in humans and mice, we have seen people, particularly when we do 8 to 9 hours time restricted eating, then both in human and mice we see mild elevation of ketones. So it'll be interesting to see how much of benefits of TR is also going through ketones.
That does make sense. Dr. Deep Dixit at Yale reached out to me years ago, and we had published a paper in Nature Medicine on beta-hydroxybutyrate as an endogenous metabolite associated with lowering inflammation through the NLRP3 inflammasome. So one of the things that jumped out of his metabolomics with calorie restriction was beta-hydroxybutyrate was elevated. So we did a study, incorporating a ketone supplement to elevate that, and saw suppression of this inflammasome. So I do wonder of the effects of ketone bodies and their effect on circadian biology, and would like to disentangle. It might be interesting to disentangle the effects of time-restricted feeding and how different metabolites contribute to the benefits of that. With beta-hydroxybutyrate being elevated only after a certain time point, maybe 12 hours or more. So for maybe the last part of advice, if someone is interested in time-restricted eating, what is the easiest entry point? Is it, fasting for eating within a 12-hour window, maybe starting there, or pushing it further, 18 hours, 20 hours?
So I think for most people, it will be easy to start with a 12 hours window, because when they start with 12 hours, they also try to figure out what are the barriers, personal barrier, whether your work schedule doesn't permit, or family barriers where you have to eat with your kids or loved ones. And you also need their support because invariably you will end up reducing some extreme meals, either late night. And then you can try to go down to 10 hours, because in most of the time restricted eating that are long term, what we find is 10 hours time restricted eating is more sustainable over time than 8 hours or 6 hours or 4 hours. If you're a loner, maybe 4, 6, or 8 hours might work, but in most social settings, 10 hours seems to be the sweet spot. And what we're also saying is people can eat outside that 8 or 10 hours. They can go to 12 hours once or twice a week, but they still get all the benefits of time restricted eating.
So it's great to know, you don't have to fast for 12 hours or beyond, or 18 hours or even 20 hours like a lot of people are doing. And my concern is that some people are taking this a little too far. They look at your work and then they're, fasting 22 hours a day every time, where I think just doing 12 hours may be ideal. And for me, I tend to lose weight if I do too much time restricted feeding. And so to maintain my weight, doing something like 18-hour fasting is it's hard to maintain your weight if you have a fast metabolism. But I think it's an amazing tool for so many different effects, particularly on metabolic health. And thanks again for doing this interview.
Have a nice day. Thank you.
Thank you, Dr. Panda. Bye-bye. Thanks for tuning in to this episode of The Metabolic Link. If you've enjoyed this podcast, please share it with others, leave a comment, leave a review, and also follow us on social media at Metabolic Health Summit. We look forward to seeing you next time. Thank you.